You know that feeling when an online store seems to know exactly what you want, sometimes even before you do? Well, that's not magic, and it's not a coincidence. It's machine learning. And today, we are pulling back the curtain on customer segmentation, the science of how businesses use data to turn a giant, faceless crowd into a crystal clear picture of, well, you.
All right, so here's our roadmap for today. First, we're going to talk about the why, the big quest for segments. Then we'll get our hands dirty and see how the raw data gets prepped. After that, the really cool part, we let the machine find the hidden groups. And finally, we'll see what those groups actually mean for real-world businesses.
So let's start at the beginning. Every single company, I don't care if it's huge or tiny, has the same basic problem. They have tons of customers, but they can't possibly talk to every single person one-on-one. So they have to find a smarter way to understand the main groups within their audience.
And that's the million-dollar question, isn't it? How do they find you in a sea of other people? They can't know you personally, of course, but they can know your data. And by looking at your data, they can find other people whose data looks a whole lot like yours. This is where it all starts, seeing patterns instead of just a mass of people. And this whole process has a name, customer segmentation. It's all about finding those common threads, what you buy, how often you shop, maybe even things like your marital status, and grouping you with people who share those traits. The goal? To stop shouting at everybody with the same message and start having more relevant, almost personal conversations.
Okay, so before any machine can start finding these cool groups, it needs fuel, it needs data. And let me tell you, that data almost never arrives in a neat, tidy package. It's more like a chef getting a crate of vegetables straight from the farm, still covered in dirt. You've got to clean it up and prep it before you can even think about cooking. And here's a little snapshot of what that raw data often looks like. See? It's a bit of a mess. Notice that NaN under the income column? That means the data is just missing. An algorithm can't do anything with that. And what about this Z_cost contact column over here? Turns out it's just noise, some leftover data that doesn't tell us a thing about the customer. It's junk. So yeah, we've got some cleaning up to do.
So we start our data kitchen prep. First up, we clean the spills. We find those 24 rows with missing income data and just get rid of them. Step 2, we throw out the junk. Those useless columns, gone. And step 3 is maybe the most important. We have to translate, because as you're about to find out, our machine speaks a very, very specific language.
And this is just so important to understand. An algorithm has no idea what married or single means. It's just letters to it. It only gets one thing, numbers. So a huge part of the prep work is turning these words into a code it can understand. Maybe single becomes a 0, married becomes a 1. Now finally, our data is in a language the machine can actually read.
All right, our data's clean, it's prepped, it's translated, it's ready. Now for the really fun part. It's time to hand over the keys to the machine and let the algorithm do what it does best. This is where the real discovery happens. Now, the technique we're using here is called unsupervised learning. The word unsupervised is key. It just means we're not telling the machine what to look for. We're not saying, hey, go find us the big spenders. No, we're just dumping all the data on its desk and saying, you tell us what the natural groups are. It's exactly like being given a warehouse full of unlabeled boxes and having to sort them into piles based on their properties without ever knowing what's inside. And that leads us to the big, looming question. Just how many groups are actually in there? Is it 2? Is it 10? 20? We can't just guess. We need a smart, mathematical way to ask the machine, hey, how many distinct clusters do you actually see? So how do we find that magic number? Well, we use this really clever trick called the elbow method. Basically, we ask the machine to try sorting the data into different numbers of clusters, say 4, then 6, then 8. And each time, it gives us a score called inertia. Just think of inertia as how messy or spread out the groups are. A lower score is better, meaning the groups are tighter. We're looking for that elbow point on the chart, the spot where adding more groups doesn't really help tighten them up much more. And look at that. The sharpest bend, our sweet spot, is right there at 6 clusters.
And there it is. The machine has spoken. After crunching all that data, sifting through thousands of customers, it found the ideal structure. This isn't a guess. It's not an opinion. It's a conclusion driven entirely by the data itself. There are 6 distinct, meaningful groups of customers hiding in plain sight. Not 5, not 7, 6.
And this is just a beautiful visualization of what the machine actually did. It takes all of that complicated data, which has way too many dimensions for our human brains to picture, and it flattens it onto this 2D map. Then, the algorithm goes to work coloring in each dot, each customer, and assigning it to one of those 6 groups it found. It is literally creating order from chaos.
Okay, great. So we have 6 clusters. But so what? I mean, a bunch of colored dots on a chart is cool to look at, but it doesn't help a business sell more t-shirts. Now we have to do the final, most important step. Translate these abstract, machine-made groups back into real, human customer profiles. And this, right here, is where it all pays off. This is the whole point. Once you know who your 6 groups are, you can do amazing things. Maybe one group is high-income, occasional shoppers, and another is young, frequent buyers. Well, you can stop wasting money sending discount codes to the first group and instead show them your luxury items. And you can hit that second group with a loyalty program to keep them coming back. It goes way beyond just ads. We're talking smarter inventory, better products, a more valuable and efficient business, top to bottom. So I'll leave you with this thought. The next time you're scrolling online and you see an ad that feels just a little too perfect, a little too specific, ask yourself, was that ad really for me, the individual, or was it for my cluster, the data-driven persona that a machine learned I belong to?